All right, ladies, hello and welcome to our populations note video. So the first thing that we need to do is define a population. Now, a population is a group of individuals that belong to the same species and live in the same geographic area. So in order to recognize a population, its geographic boundaries must be defined. So what that means is that regardless of where we're talking about, what species, we have to define those geographic boundaries. Now, we could be talking about the woods that's in your backyard. We could be specifically talking about a population that's in just Lucas County, or we could be talking about a population in Ohio. Regardless of what we're talking about, we have to define where we're talking about that population. So let's move on to some characteristics. The first characteristic of a population is its range. The range is a geographic area in which a species can be found. It's often presented on a map. So if we're talking about some organism, maybe that species is found in the Northwest and in the Southeast. We just show where that species can be found. The next characteristic of populations is density, and that's the number of individuals per unit of area or volume. So for example, maybe we have 4 bugs in this little area. This is, let me put area here. This would be 4 bugs per, let's just say, meter squared. Or we could do it in volume. Maybe we have a fish tank and we have 2 fish per meters cubed. So area is squared and volume is cubed. The next way that we can talk about populations is through distribution. Now, distribution is how organisms are spread out over a space. There are 3 types. There's random, uniform, and clumped. I'm going to put random in the first box, uniform in the second, and clumped in the third. So random, in a random distribution, the individuals show no regular pattern in how they are distributed. There's little social interaction between individuals. So if we're plotting what some individuals, where they live, it's kind of just random, right? That's what it means. It's random. Uniform distribution is when a population shows uniform spacing between individuals. They may become territorial because of this, and they might have some type of competition going on since they're sharing this space. They're all close together. So uniform is going to look something like this, where it's kind of consistent throughout the population. They're spread out pretty even. Clumped is when typically social animals, family groups, or in colonies during swarms or when food and shelter is patchy. So clumped kind of means just they're hanging out as a group for whatever reason that might be. And it might be based on the type of animal that they are. It might be based on if there's food or shelter somewhere. So that's kind of what a clumped distribution looks like. So let's shift over now to growth rate. So a growth rate describes whether the population size is increasing, decreasing, or remaining constant. Population size is affected by, oops, let me get rid of that for you, is affected by birth rate and also death rate. If the number of individuals born is greater than the number of individuals that die, then the population may grow. So there's two types of growth rates. We have exponential and logistic. So we're going to start with exponential. An exponential growth rate is a growth at a constant rate of increase per unit time. Now, if we were to graph that, this would be a number of individuals and time on the x-axis. Under ideal conditions with unlimited resources, a population can grow exponentially, producing a J-shaped curve. So that'll look something like this. That would be exponential. The other type is logistic, so another type of growth. Logistic growth is growth that increases growth that increases at a constant amount per unit time. Logistic growth occurs when a population's growth slows and then stops following a period of exponential growth. So what does this look like on a graph? Again, we'll have our number of individuals on our y-axis and time on our x. And it starts kind of exponential, and then for whatever reason, it starts to level off. This leveling off portion is the logistic part. So this can happen if resources start to become limited. So that might be food, that might be shelter. Okay, the next part of this is on the next page. So carrying capacity. So carrying capacity is, let me make the graph for you. It kind of is like a logistic curve, but a little bit different. So it looks something like this on a graph. We would kind of start exponential, and then we start to really level off, like pretty straight. And this part is the carrying capacity. So carrying capacity, I'm going to go down here, is the maximum number of individuals of a species that can that an environment can support. So you might be wondering, how can this happen, right? Why would the growth rate start to slow? It can be because of two reasons. Either the birth rate decreases or the death rate increases. So when the birth rate and death rate begin to equal, the population growth stops. Population size will level off at the carrying capacity. Separately or collectively, limiting factors determine the carrying capacity of an environment for a given species. And we'll talk about these factors in the next note session. But that concludes this session. If you have any questions, please come find me and we can talk about it one-on-one.